In this video, we're going to be going over some example problems of graph stacks and how to kind of better use a tangent line to figure out what our graph is doing. So let's get started. So you might find yourself wondering, what is a tangent line? Simply put, a tangent line is just how we can draw a line where it touches only a curve at one single spot. So for example, we have this curve here on the left. If I wanted to draw a tangent line at this point right there, I need to find a way where I can draw a single straight line so that it only touches that one point. And there's really only one way we can do this. And so you just take a ruler or straight edge or whatever and draw a line in as best you can. And then using like normal algebra rules, we can find the slope of this line, and that would give us the rate of change for our graph right there at that point. So taking a look at these graphs, if I look at the first one that we have, and I decide I'm going to draw tangent lines at each one of these points to see what the slope's doing. So I can draw the tangent line at each one of these points. And if you notice, all those tangent lines are the exact same. So the slope is the exact same the entire time. So if we have a positive constant slope, my velocity is going to be a positive constant number. And then same thing for the acceleration. I would look at the slope of that horizontal velocity line, and the slope of all horizontal lines is 0, so my acceleration is 0. For the next one, I have a constant positive slope for my first little interval. So on my velocity graph, I draw positive constant velocity right there. And now if I was going to draw little tangent lines along that curve, my first one would be a steep positive, and then as time goes on, those tangent lines are getting less and less steep. And so my velocity is getting less and less positive. It eventually goes to 0. And then for the acceleration, that first interval, the slope of this horizontal line is 0, so the acceleration is 0. And then my second part has a negative slope right here, a constant negative slope, so my acceleration is a constant negative value. For my third one here, the slope starts flat, so I know that my velocity starts at 0. And as time goes on, the slope of these tangent lines gets steeper and steeper in the positive direction. So my velocity graph gets bigger and bigger in the positive direction. Then when I go to draw the acceleration graph, that velocity is a constant positive slope, so my acceleration is a constant positive value. For my next one over here, my position starts here where it's actually flat. The tangent line would be flat, so 0. So my velocity starts at 0. And as time goes on, these tangent lines of the velocity graph are getting steeper and steeper in the negative direction. So my velocity gets bigger and bigger in the negative direction. And then for my acceleration graph, it is to get my acceleration, when I look at the velocity graph, it is a constant negative slope, so my acceleration is a constant negative value right there. For this last one here, it's a little bit different because now we're given the velocity graph to start with. So if you notice, the velocity graph starts at a big positive number. That tells me that my slope of the position graph is going to start really steep in the positive direction. And as this line decreases its value, the velocity decreases to 0, that means the slope of my position graph is going to be positive the whole time, but slowly flattening out till it's flat. So I'm going up, it's flat there at the top, and then as this velocity graph starts to get bigger and bigger in the negative direction, that means the slope of my position graph is going to be going steeper and steeper in the negative. So now I basically just start curving back down. And then for my acceleration graph, I just need to look at the slope of my velocity graph. That is the entire line right here for the velocity graph. It's negative. This whole thing has a negative slope. And it's a constant slope. So then the entire line is a negative acceleration right there. So to get all of these at the end together, there we go.